Hi viewers, welcome to my channel. In this video, I'm going to teach you few case study problem which is released by CBSE Question Bank. Okay, before we enter to the case study problem, we should clear with what is a case study, right? So case study is nothing but they given a situation, real life situation problems. From that situation they will raise a few questions, right? So they will raise a few questions, so you need to answer the question, that's all. Now we can into the case study problem. Chapter number 1, real numbers. So here CBSE they given, CBSE question bank they given case study problem number 1. To enhance the reading skill of grade 10 student, the school nominates you and two of your friends to set up a class library. There are two sessions, session A and session B of grade 10. There are 32 children in a session A. So you need to take down session A 32 children and session B 36 children in a class B. So from this situation, from this from this three line, what is the given thing? That is a session A 32 students and session B 36 students. That's all, right? So whenever they given any case study problem, first you just read the statement and try to get the information from the statement. So in the statement, the information is there is a session A 32 children and session B 36 children. Clear? Okay. Now we can enter the first question. So it is a situation now. So from this situation, they have raised the first question. What is the minimum number of books you will acquire for the class library so that they can distributed equally among the students of session A or session B, right? So they have asked a question, what is the minimum number of books you will acquire for the class library so that they can distribute it equally? So we have a confusion in this whether we should find the LCM of this two number or HCF of this two number. So it is very easy. Here we have clue word that is a minimum number. So they given a clue word minimum number as well as the one more clue word distributed equally. So here the two words are the clue word. So we need to find the LCM of this number, right? Okay. Now first question subdivision number. So case study 1, subdivision 1. We need to find the HCF of this two number. Sorry, LCM of this two number. So we all know how to find the LCM of 32 and 36. As usual, you can go with the prime factorization method. So prime factorization method, find the prime factors of 32 first. So the prime factors of 32, we can go with the 2 first. So 1 2s are 2 here, 6 2s are 12. Next 2, 8 2s are 16. Again 2, 4 2s are 8. Again 2, 2 2s are 4. Again 2, 1 2s are. Right? Clear? Next, now we can find the prime factors of 36. So here also you can go with the minimum number, minimum prime factor, the smallest prime factor, that is 2. So 1 2s are 2, remaining 1, 16, 8 2s are 16. Again 2 table, so 9. Now the 2 will not divides 9. So go with the 3 table. So 3 3s are 9. So 3 1. So now we have found the factors. What are they? 32 equal to 2 2 2 2. So 5 2s are. So 2 into 2 into 2 into 2. Next for 36 the prime factors are 2 into 2 into 3 into 3. So now we need to find the LCM of this number, right? So LCM of this number is nothing but the product of the greatest power, right? So the product of the greatest power of each prime factors. So the product of the greatest power of each prime factors. So here As usual, here we need to take a number. The number should be occurs most of the time. Here when you're considering 2, here 2 occurs 5 times, here 2 occurs 2 times, so you can go with the 5 times. So 2 into 2 into 2 into 2 into 2. Next, coming to the point of 3. So 3 occurs here only 2 times, so you can take it 2 times. 3 into 3. Now you should multiply. 2 twos are 4, 4 twos are 8, 8 twos are 16, 16 twos are 32, 32 threes are, so 32, 3 threes are 9. So you should multiply. 18, remaining 1, 1 9 threes are 28, so 27, so it became a 28. So the LCM of this two number is 288. So in this option, C is a 288. Have you all clear? So when they given a situation problem, you need to understand the situation. Then from the question, you just find out what supposed to find, whether it is a LCM or HCF, right? Okay. Now we can move to the second question. Ah, yes. Second question: if the product of two positive integer is equal to the product of their HCF and LCM is true, then the HCF of 32 and 36. Yes. So we know this statement, right? We know this general form, right? Statements and general form. Actually, subdivision number 2, LCM of a two number a comma b into HCF of a two number a comma b equal to the product of the two numbers, right? We all know this. Clear? So we can use this statement, we can use this to find the HCF of a given number. So they have asked a HCF of 32 comma 36. So HCF of 32 comma 36. So now we can apply the formula. From the first question, we know that LCM of a two number 32, LCM of 32 and 36, we know that it is a 288. Now we can find the HCF. So very easiest one. So HCF of 32 into 36 into LCM of 32 comma 36 equal to A into B, that is 32 into 36. Now I know that value for LCM of 32 comma 36. So HCF of 32 comma 36 into LCM of 32 36. I know that what it is, 288. So 288 is equal to 32 into 36. Now HCF of 32 comma 36 equal to 32 into 36 divided by 288. When we are cancelling this, we will get the value 4. Are you all clear? Any doubt? So it is given in the statement. Without using this also, you can easily find the HCF of two number, because we know that here 32. So we need to take a greatest common factor. So here the common factors are 2, 2, here 2, 2. So when you are taking 2 into 2, 4. So the HCF of two number is 4. Right? So the option is B. So the right option is B. Have you all clear? Any more doubt? Okay. Second question next. Third subdivision. So in this third subdivision is a very easiest one. They given 36 can be expressed as a product of its prime factors as. So already we have found here. So then 36 can be expressed as a product of prime here. So 36, we can write 36 as a equal to, that is here 2 2. So 2 square into 3 square. So the answer is 2 squared and 3 squared. So where is the 2 squared and 3 squared here? Option A. Option A, 2 squared into 3 squared. Have you all clear? Okay. Next, fourth question. So here fourth question. Even a fourth question also very easiest one. 7 into 11 into 13 into 15 plus 15 years. Actually, they given a one expression. with arithmetic operation, we need to find out when you are simplifying this, we will get a composite number or prime number or neither a prime or not composite or none of this. So whenever they given this kind of statement, you need to check in the first expression 7 into 11. Listen here. 7 into 11 into 13 into 15 plus 15. So this are all this three this all the four terms under the multiplication. So from this we should take a common 15. So 15 is a common, you should take common. So remaining here 7 into 11 into 13 into here we have taken a 15 as a common. So remaining 1. So plus 1. Clear? Any doubt on this? Okay. Next, now it is in a form of 15 into some term will be there. So obviously it is not a prime number because here it is a factor. 15 into it will come some number here, right? When you're simplifying this, we'll get a some number. So 15 into some number. So the number can be written as a 15 into some number. So it is not a prime factor, right? We can simplify it also. It's not a prime number. So obviously it is a composite number. We can find it. So 77 into 13 plus 1. So now we should multiply 77 into 13. 3 sevens are 21, 1 remaining 2. 3 sevens are 21 plus 2, 23. 1 sevens are 7, 1 sevens are 7. So 5, here 9. So 9, 51 plus 1. So 15 into 9, 52 is the answer. So now it is the number when you are expressing, when you are simplifying this number, I will get 15 into 952. Again, I have the 952 also some factors. So here the number is when number is have a factors of 15 and 952. So obviously it is not a prime number. So it is a composite number. So the option is B, composite number. Have you all clear? So we have a mnemonics also. When they given this kind of problem, you need to check whether here 15 is there. The same number should be in a after plus and before the plus. You can check it whether the 15 is there or not. 15 are same number. 13 13, 11 11 or 12 12 same number there or not. After the plus and before the plus. Right? If it is there in this kind of expression, it is obviously a composite number. Right? Okay. Next. Last question, fifth one. So in this fifth question, if P and Q are the prime integers such that P is equal to AB square and Q is equal to A squared B, where A and B are the prime numbers, then LCM of P and Q is okay. Actually, they given a some expression, right? That is P is equal to what it is a b squared, then q is equal to a squared b. So they said it is a and b are the prime numbers, so it's the prime factors. So the p is also expressed as a product of primes and q also expressed in the form of product of prime. So I need to find the LCM. So it is very easy. Now in this a, you need to take for LCM, we need to take a highest power, right? The greatest power of each factor. So the factor is here a square. So which is the greatest power? A square. So you can take a square alone. Next here b square. So you can take a b square. So the answer is a square b square. So the option is B, a square and b square. Have you all clear? Any more doubt? Thank you for watching my video. Thank you all of you.